Hi, this is Robins and I'm going to talk about my final project for ENME 489Y remote sensing. For this project, as a background, we had to create a system that can scan a target on campus. The point of this project was to teach us how LiDAR systems work and how they don't work through hands-on experience. So for this project, my target was a dog poop, trash and bag collector. The target was located at Terrapin One. It was chosen because it is unique on campus and has three distinct parts. The first part is the trash collecting cylinder. The second part is the bag dispenser. And the third part is the warning sign. Okay, so now I'm going to talk about my sensor. As you can see, my sensor is composed of a Raspberry Pi with a Pi camera and an Arduino. All of these are powered by power bank, as you can see. For my sensor, my Arduino is simply powering a laser, which acts as the transmitter for the LiDAR system, and the Pi camera acts as the receiver and takes in the light that the laser is outputting. As you can see, the sensor is on a tripod, which allows me to adjust the angle of the sensor as I see fit. Also, the sensor to measure the angle, usually I use my phone, which will be located around here, which gives me the angle that the sensor is currently at. For my sensor, everything was put together mostly with, as you can see, with tape. The tripod was put together with tape. The two sides of the chassis was put together with tape. It's kind of hard to see, but the wires were hot glued to the Arduino, and the Raspberry Pi was put together with twisty ties, and the camera was put together with elastic bands. And for the sensor, the laser chassis had to be widened so that the laser could fit in, and that's how the LiDAR sensor works. So now I'm going to talk about what is remote sensing. Remote sensing is the process of collecting data about something without direct physical interaction with the object. There are two types of remote sensing. There is active remote sensing, which is when the sensor sends a signal that is returned back and detected by the sensor and then processed. And there is passive remote sensing, which is when the sensor is simply receiving data that's already available, such as sunlight or something similar. Now I'm going to talk about what is a LiDAR. A LiDAR stands for light detection and ranging. As you can see from the name, it is when light is used to detect something and measure its distance. LiDAR is used to map forests from height, map objects such as buildings, or even things that might not make sense, such as wind. So now we're going to talk about computer vision. Computer vision is The process of detecting and categorizing data such as human faces, dog faces, or something similar with a computer algorithm. So now I'm going to talk about how remote sensing applies to my project. My project applies to remote sensing since we're collecting data about an object, my target, which is the pug trash bag collector, without physically touching it. And this process is done through active sensing, where we send a light signal that is reflected off the target and received by the camera. Hi, so I'm at my final part for homework 7 to record the three sides of the trash collector. For my three sides, I'm going to use the front straight on as the first side. I'm going to use 120 degrees off at the second side and another 120 degrees off at the third side. I didn't capture the back side because there's a tree there, and with the tree the LiDAR will be too close, so you won't be able to accurately collect data. As you can see, my project is in the worst lighting condition ever. There are multiple bright lights around, so it's really hard to capture anything. For my homework 6, I was barely able to get any data at all, since the LiDAR relies on point clouds. You can't see anything that's really far, as the light pollution just blocks all of the light coming out. So that's it. The scanner still works the same way. There is a laser pointing to the target, and there is a Raspberry Pi with the camera taking a picture, and then I use my laptop, which battery has died, to take the picture and process it into the point clouds. Alright, that's it. Bye. My main challenge with this project was that my target was under two bright lights, which means that it was extremely hard for the LiDAR to detect my target. And even with long exposure, the target was still not very detectable. In fact, sometimes it even got worse, as there was even a saturation of light. This was a challenge I could not really overcome. There was a lot of noise in my data from from these lights, and no matter how much I filter my data, it was extremely noisy. Hi. Uh, so this is how I process my data for homework 7. First, after I capture a few of the pictures, I use colorpicker2.jpg to find the HSV values of the picture. As you can see, for this one, I have alignment images left, which are the images on the left side of the target. And using color picker, I found that most of these images cannot be used at all. When looking at it, they are just too bright, like the laser is not picked up at all by the camera. So for my final data collection, the only data set I could use was the front, because both the left and the right data side were printing to bright lights, so the laser wasn't captured at all for both the left and the right side. So to generate my 3D cloud, I only had the front side that I could use. So using Color Picker, it's not shown here, but the first thing I did is I I found the HSV values for the front side, which were 145, 65, and 0 as the lower bound, and 255 to 55 to 55 as the upper bound. Then using that, I went to data generation.py, and I changed the lower bound to 145, 65, and 0. And I used the file at element image front. This text is from when I was going to try the left and the right side of the images, but they didn't pan out. So as you can see, I opened all of the file from the front, and then I put it in a processing file called test result open, the result front.txt, and I get a 3D printing cloud from Python. Yeah. This 3D printing cloud is not very useful because it's not very easy to see. So I had to use MATLAB to process the 3D cloud. As you can see, we go to open3dcloud.m and MATLAB, and we run it to process. As you can see, it's giving an error. 3D cloud project data processing. This is the final point cloud I decided to go with for my project. As you can see, most of the data was discarded. Since it was so bright, the entire the entire trash pot collector did not show up since it was so bright and there were many holes. And as you can see, only the darkest part of the bag dispenser show up. As you can see, this will be around the top part of the bag dispenser. This will be the side of the bag dispenser, and this will be some of the bar that's connecting the bar dispenser to the trash bag dispenser. I tried to get more data, use more HFC filters, but this only resulted in more noises since there wasn't anything to see that well, since it was so polluted with light. And that's it.